It's 10 o'clock and we're live. Good morning, everyone, and welcome to the PROSTEP Insight Days 2023. We're so pleased to have you with us again. You may be familiar with the format from last time, it was online as well. This time we've gone one step further. There are 2 days of sessions, today and tomorrow, during which we'll be discussing PROSTEP AG's solution and consulting services in great detail. Just to briefly introduce myself, my name is Julia Bauer, I am a TV and event host, and I guided you through the sessions last year. I'm pleased to be back again this year. We have one overarching theme for the next 2 days, which is the challenges of the digital thread. We've planned 4 sessions for you today. The first one begins now at 10 a.m. During this session, we want to shed light on the challenges of the digital thread within businesses. Then at 12:30, we want to look at the challenges of the digital thread in the supply chain. Then at 3 p.m, we want to turn to the roadmap, what is in the product pipeline at PROSTEP. And then at 5:30 p.m, for our English-speaking colleagues, we will have a summary of the whole day in English. And that recap session is called Designing for Consistency, Strategies for Achieving Digital Continuity Across the Digital Thread. So we have a lot in store for you. Something that's very important for us, though, is that we don't just want to pass on information to you. We want it to be a little more interactive and have our customers speak as well. And perhaps more importantly, we want to hear from you as well. So should you have any questions, please get in touch at any time, of course, digitally. In the bottom right of your screen, you should see a small comment box called Q&A. Please type in your questions here at any time. And at the end of each session, we'll have time for questions. I will see your questions on my tablet and can put them to the speakers. So this should mean that all of your burning questions should be answered. So please don't hesitate, just ask. So far so good. This is our agenda for today. Should you miss any of our sessions or have any colleagues who can't make it today, don't worry. The sessions will be recorded and then uploaded to the PROSTEP video portal. That might take a few days. So then you can watch the videos again, share them, and there'll also be an English translation available. The idea is that the information provided during these Insight Days can be watched and shared in the future as well. So let's get started. I'm pleased to introduce our first speaker today, Mirko Theiss, who will introduce us to our subject for today. He is a board member of PROSTEP AG and is responsible for both products and sales, among other things. I'm delighted to be able to welcome him here. You have the floor.
Thank you very much, Ms. Bauer. And welcome from my side as well. I'm really happy to welcome you here. 2 days of the PROSTEP Insight Days. The core issue is digital thread, and I'd like to start with a brief introduction to the topic and the positioning, which shows the challenges and our solutions we offer surrounding this. Digital twin, or also digital thread, is the core of many concepts in engineering, manufacturing and operating technical products, cars, systems, machines. And in total, it stands for an entire ecosystem of methods and tools. Things like systems engineering, Industry 4.0, Internet of Things, all come together here and would have to be processed within one concept, and it promises new fields of application. Classics are things like predictive maintenance, augmented reality, which can be accomplished based on such solutions or approaches. We want to generate new benefits for this, reduce costs, access new business, and at the end of the day, offer new solutions for enthusiastic and thrilled customers. We've been dealing with this topic for a long time already, and by way of example, we have worked on a huge number of use cases which show where the digital twin and digital thread can be applied in reality. We've broken that down. In development, we call that digital twin as designed, classic, DMU. For years now, this has been state of the art, but also things like digital backup, test and validation processes being made in development, that's state of the art already, and digital twin are already long in industrial reality. In the middle, the red area, digital twin as built, as in the factory, digital data of the product and the digital data of the factory come together. You can plan factories or manage complete data-driven factory management, or also a virtual start of a system or a machine before physical start of the machine. For that, we need different approaches which unite production data and development data. Then the third area, digital twin as operated. That means the product is in operation. A typical case is predictive maintenance. That means looking ahead. Maintenance intervals or maintenance work can be predicted so they've been carried out at the right time and massively save costs that way. But there are a huge number of other cases like augmented reality, over-the-air update of software for vehicles, machines, smart updates, etc., etc. All of this is very promising. New applications, also new fields of business. What's important here is the dotted line. It says change of ownership here. Classically, a product after it's been produced is sold to a customer. And that means there is a certain break in the system. That means the manufacturer of the system no longer has access to the data only when he signs respective service contracts. And that's a bit of a problem because in reality, particularly in complex products operated in a complex environment, such a coupling is not that simple. To overcome this, one of the approaches which I consider to be absolutely pertinent is product as a service. That means not even to sell the product at all anymore, that the product is offered together with the service. That means the customer doesn't buy a machine, he buys an operative machine, including the service, all the way to concepts in which the staff can even be supplied together with the machine. That's the master use case in our scenario, because if I can offer that as a company, then my development data, my operational data, and product data have to be united properly along the chain, but they also have to flow back into development so that my product can be successively improved. Because this master use case, product as a service, is a completely different business model. Classic engineering companies mainly earn money in servicing a machine. But if I sell the machine including service, then obviously I want to minimize service as far as possible. I have to earn money with the overall concept and produce minimal operating costs. So that requires that I can successfully improve my product in order to make a profit in the long run. How do I do that in reality? Because the next 2 days it's going to be about digital twin and digital thread. What does that mean with respect to my PLM ALM architecture? We can see on the left our digital twin, in the center of all these concepts. On the right-hand side, our PLM architecture. Today, in most companies, that's made up of a whole lot of databases, team management systems, ALM systems, somewhere 3D data, electronic data, software stored, managed, versioned, released, then it goes into production. Later on, test and validation follow, and then partners keep working on that as well. That means I'm using parts from partner companies, modules, possibly also software from a partner, electronics, behavioral models, architecture have to be integrated in my own product architecture. And all of that is endlessly complicated, but that's what I have to do. I have to manage the link of my data between all of these data pods. We call that link data, and then the next step, you have to generate traceability. That means I have to understand what requirements relate to which product, what tests what requirement, and at the end, what operational data belong to which function, and how is the whole thing linked in order to find mirrors. And in order to do this properly, or to make the whole thing logical, we work together with customers and create ontologies. That means a semantic description of the data and the way they're interconnected, and that is the framework which forms the digital thread at the end, the ontology. The logic is described and the linked data generating traceability. When I have all of that in total, then I can establish new applications, set up new fields of business, and then the digital twin and digital thread are in symbiosis and can work together. One word about artificial intelligence at the end. It says here one of the key applications. Very often it's argued that based on a data legs that could all be accomplished. Generally I see that differently. I think engineering is a precise science. You need precise connection between data And if you set up the digital thread properly, you know the logic, then artificial intelligence can be let go on this. Over the next few days, we're going to present our PROSTEP products, our services in consulting. We're going to do that based on the example of the Mars rover. That's a model we set up initially based on a set of NASA data. This is the third or second generation, real hardware, real software electronics. And based on this test bed, we develop our products and our consulting offer. And there, our colleagues are going to use this specific example to guide you through these topics. We'd like to start with a brief film of our partner Siemens. And the real Mars rover was also developed together with Siemens development methods and tools, and our colleagues will present that in their film. My name is Klaus Löffel, and I am the CEO of Siemens Software Germany, Austria, Switzerland. We're going to be talking about digital thread today. Digital thread is important for societal topics like, for instance, shortness of talent or sustainability. Digital thread is also important in order to work in ecosystems. Model-based approaches, like for instance in system engineering, help us to manage this complexity. Another exciting field is the connection between automation and software, the so-called IT-OT convergence. We would like to invite you to address all of these topics, and our motto is "The sky's no limit," and our example with the Mars rover fits this very nicely.
Every space mission is uniquely challenging, but success of the JPL Curiosity rover Mars Science Laboratory required a level of complex engineering and planning beyond any other mission to date. The team had to design a vehicle to house the world's most advanced scientific laboratory in a space rover, plan how to safely transport a 1 metric ton payload, and plan how to safely land it on Mars, all in a virtual environment. And there was zero margin of error. Siemens PLM software gave the JPL engineering team confidence that their decisions through design, build, test, and validation would result in success. The rover is made up of tens of thousands of parts that needed to work together to get through launch and beyond. The 2-year scientific mission required a redundancy of systems, which doubled the density of the systems on the rover. But the trick was that the size and volume of the payload could not increase. JPL engineers used Siemens PLM software to help design and test the parts before assembling the system. Extreme temperatures posed another major mission-critical challenge. Thermal analysis ensured the team that the Curiosity rover, all of the sophisticated instruments, and the spacecraft that housed it all could endure the extreme temperatures. Curiosity's total mass is 15 times larger than the science instrument payloads of 2 previous Mars rovers. Innovative maneuvers and technology to land a heavier spacecraft with greater precision were also developed and proven using Siemens software. And Curiosity made a perfect landing in August of 2012. PLM software technology from Siemens was also used by JPL engineers to design and simulate the 10 highly sophisticated science instruments aboard Curiosity. These are now successfully being used to send lab results of rock samples back to Earth to analyze and determine whether conditions were ever favorable for microbial life on Mars. During the rover's 2-year mission, experiments like these will help us learn more than ever before about the Red Planet. the smallest mission detail to the most complex engineering feat, Curiosity proves that Siemens PLM software is mission critical for a trip to Mars. Imagine what Siemens PLM software can do for you here on Earth.
Enjoy. I'm looking forward to meeting you personally at the Insight Days 2023.
Thank you for that. And I think it's now the right moment to find out how these sorts of complex development processes can be controlled in OpenCLM and how traceability can be made possible. And that's something that Rainer Zeifang can help us with. He is the Chief Technology Officer of Daimler Projects at PROSTEP and also responsible for PROSTEP's digital thread solution OpenCLM. I'm very pleased to be able to welcome you here today, Mr. Zeifang. You have the floor.
Thank you very much, Ms. Bauer. Carsten Theiss and Klaus Löckel have shown you how important digital thread is in product development. We're going to show you a case study with the Mars Rover and show digital thread in product development. The Mars Rover, as it's just been presented, is a product which combines mechanical, electronic and software components and therefore is a complex product. I'm going to show you how complex drivers are in product development and how PROSTEP products can support you to manage complexity. The complexity lies in the complexity of the products themselves. Some people call them smart connected products, others cyber physical systems. These are typically developed in a V model. That means you start with the requirements, move on to systems engineering, through design of the mechanical components, the design of the electronic components, and then the software. In this vertical direction, traceability of your product development has to be ensured. Then verification and validation begins. Again, product components towards the overall product. And at this point, it is important that the horizontal traceability can be ensured between the development artifacts. That's the first driver of complexity. The second driver of complexity stems from the plurality of domains which are involved in the product creation process. All of these domains work with their own tools and their own data, but they're definitely networked amongst each other, and that has to be understood and that has to be traced. And the third point, which is just as important, is safety and regulations. You have to ensure that what you have developed really works and can be operated safely. Homologization plays an important role, but also things like digital product path come into it, which is that product data have to be saved in a digital format and comprehensively. Those are the drivers that we have. And it's exactly at this point that OpenCLM steps in. With OpenCLM, we are creating a tool which offers a digital thread throughout all available product domains. What is special is that data are not copied from domain systems, but only linked and referenced. And that way, traceability is ensured throughout all development artifacts, regardless which domain they stem from. Here we're focusing on development environments which are made up of a plurality of various systems, and that way cross-domains product decisions can be made. Now, what exactly is OpenCLM? OpenCLM is a lightweight, smart, web-based solution which allows you to achieve digital thread throughout domains. We support various case studies. Looking forwards in development, it's about process control, progress control, and change management. Looking back retrospectively, things like impact analysis, and these 4 application cases will be seen in the demo later on, but also things like error management. We get data from operations, for instance, and we want to find out what the cause for that could be in your product design. We support that. Or things like audit support in order to demonstrate that development processes followed a particular process standard, like for instance ASPICE. All of these things are part of OpenCLM. Now let me introduce the demo scenario that we're going to be talking about. We've seen today how the Mars rover, the most recent generation, what it looks like in our company. It didn't always look like this. It used to look rather like the picture on this slide on the left. But now tests have shown that the Mars rover simply stopped working when the gradient got too steep and just stopped. And the second thing is that analyses have shown that the chassis of the Mars rover was not stable. And these 2 problems we just want to remedy. With OpenCLM, we're going to show you now how mechanical changes and software changes can be carried out, and that way the Mars rover is rendered more stable and able to operate in steeper terrain.
That's it. Thank you. That was a great presentation. So that's the theory. What about practice? We'll stick with this example of the Mars rover. Our next speaker, who will guide us through this next section, is very active in a lot of different areas. She's a product owner of OpenCLM, so the right person to have here. She's also a senior consultant at PROSTEP and a specialist in data linking and semantic web. Welcome, Anna Wagner. Thank you very much, Ms. Bauer. Following on from Rainer's wonderfully detailed introduction to OpenCLM, I would now like to discuss the applications with you and show you how our tool, our product, can support you in your work. We will go through a demonstration that will be split into 2 or 3 parts. In the first part, I'll show you what the OpenCLM structure looks like. Then I will move on to showing you applications and how projects can be structured within OpenCLM. Using our example project, working through an engineering change management process on the Mars rover, I want to show you as well how to track a project's progress. And of course, I won't keep what is really the core of OpenCLM from you, how resources from external systems can be linked to each other in OpenCLM. Specifically focusing on our demo applications, we will analyze critical components. For the Mars rover, that is specifically the chassis, as Rainer has already shown you, but also the tilt sensor and its software. And at the end of the first part, we'll look at the simulation team's analysis results to define the next steps in our engineering change management process. So let's turn to OpenCLM and see what it looks like there. After logging in, we are taken to the personalized dashboard. That is my starting point as a user. Here I can see all my tasks, projects, or configuration items, so links to information objects in other source systems where I'm involved. I can also navigate through the core functionalities of OpenCLM on the left-hand side. We have the dashboard, a list of all projects in OpenCLM, our searches, and a link editor which we can use to create meaningful links between information objects which are then used in impact analyses. But enough of that, let's jump to the demo. Here we have our Mars rover project. It's shown to us in the overview or navigator. Here you can see that a project can be structured differently. It can be structured according to product composition using CI lists where we group information objects, or according to a process, in this case our engineering change management process. Here we have process steps and milestones. We also have a graphic visualization to represent data more intuitively. and on the right-hand side, details on the individual information objects, which may include properties as well as relations. Then, switching to the Overview tab, we arrive at the project dashboard. This project dashboard is very reminiscent of the global dashboard that we saw at the start. Here we also have tasks and configuration items. But these are tailored to the project and may involve other colleagues of mine and not just me. Moreover, at the bottom of this page, we have a Gantt chart which shows the progress of the current project and any delays in the critical part. Now let's go back to our analysis of the Mars rover. Here we can jump to the identification phase of any possible changes to the Mars rover itself. As an engineer, I want to know whether I have all the information I need to work on this process step. Here we can see that we have a chassis represented in OpenCLM. The chassis is originally stored in Windchill. Just clicking once takes me to Windchill, giving me the details of the chassis and maybe even the geometry and domain information. The same applies to the tilt sensor. As a typical EE component, it's made up of the component itself, which is in Windchill. I can look at the domain information and an illustration, for example, of what this sensor looks like. And an EE component is usually also made up of software. This is attached to this configuration item and is stored in CodeBeamer. We can see the software is release 1 because this was our first version of the Mars rover. Now let's look at the process step itself. Here we can see the process is contained by a start milestone and an end milestone. We'll turn to the end milestone because I've been working on this as an example and I've collected my results in this milestone. Here is a list with all my results. My results are specifically requirements which have to be fulfilled for the Mars rover to work better. I have set out the requirements in Jira, and once again, just by clicking on this one button, I arrive at my source system and can look at the details and edit them if I see I haven't done something as I should have done. It's a great entry point to the external systems. I now want to see the analysis results of my colleagues in the simulation team. I don't know where exactly they've stored them, doesn't matter, I'll do a search, I find them immediately, it's a PowerPoint in GitLab. Once again, just one click and I can look at the slides. I see we have the problems in the chassis, and I can now go back to OpenCLM to think about how to continue to work in my engineering change management process. So that's the first part of the demo. Just to sum up this demo, then I hope we've all seen that OpenCLM can help you better understand complex relationships between different domains and source systems. We have project structures and we offer them in a flexible design to guide our users through their processes. By means of our modern user interface and the graphic visualization, it's possible to navigate our information networks intuitively. And if you do need an answer quickly and the context is irrelevant, then you can use our search. We've showed our quick search, but there's obviously a search with further functionalities and filters as well. But the core of OpenCLM, and I hope that that's come across, is that we can attach different backend systems and source systems to OpenCLM and jump to these source systems from OpenCLM by just clicking once. This means that we can pool different disciplines in OpenCLM and facilitate communication between the disciplines. I said the demo had several parts to it. Let's look at the second part. Here we'll not look at OpenCLM and its interface in quite as much detail, but instead focus on the process. We'll stick with the engineering change management process and look at how the solution development could be mapped in OpenCLM. To do so, we'll look at two components: the chassis, which has to be edited, but also the tilt sensor, which requires updated software to make our Mars rover smarter so it can avoid dangerous situations. Again, we'll switch to the source system and see again that we arrive at the dashboard. We're familiar with OpenCLM, so jump directly to the project and can look at the process phases of the engineering change management process in detail. We have the identification again, or the overview, where you can see everything. We've already talked about the identification. We have the start and end milestones, and the next step would then be solution development. This solution development starts with the end milestone of the identification and is therefore synchronized, at least in terms of time. This step is typically followed by specification and decision on the solution and the engineering implementation and production. Here, once again, milestones have been used to mark the endpoints of these phases and process steps and to enable synchronization between the process steps. Now back to our use case. We now want to develop the solution. We can split up the process here so that we have one process step for the chassis and another for the sensor. Here we can see that there are many objects which influence the process step, such as the input. The input is this component, this requirement, which I set out in Jira beforehand. And this is considered to be the input for my process step. Additional influencing factors in this process step are my components themselves. Here I have the Mars rover as a complete product, which is in Windchill, and of course the chassis. And if you look more closely, you can see that the decomposition, which is in Windchill, is also in OpenCLM, and the chassis is connected to the Mars rover, and as a result, essential, meaningful links of the source systems, which can also be present in OpenCLM to offer useful input for later analyses. Here I can look at my components in the source systems and edit them there directly. Moving on to the software of our tilt sensor, we can also see several configuration items here in the process step, which have an influence. We have the tilt sensor itself. We're not interested in the component itself here, but rather in the software. And in Codebeamer, we see, yes, it's version 1. Okay, it's been released. We need to build a new release. Here, once again, as input values for this process step, we need our requirements, which are stored in Jira, which generally say that the Mars rover should withdraw whenever it identifies difficult terrain, and ideally should avoid this difficult terrain. That has to be implemented on the software side. To do so, and we do already have a release, we have to submit a software change request. This also doesn't happen in OpenCLM itself, but in the domain software, so in this case in Codebeamer. But it's then linked in OpenCLM to create transparency. And when this change has been processed, we see it here. We can then publish our completed release in OpenCLM. In conclusion, on the first two parts of this demo, I'd just like to add that with OpenCLM, using the process templates, which can be instanced any number of times, we can support companies in carrying out and maybe even introducing processes. We can link our configuration items meaningfully with your process steps, and in doing so say whether it's inputs, outputs, or methods that have to be applied. Everyone working on this project in OpenCLM has a complete overview at all times of what is going on and can see the results that are available. Even if they don't have access to the source system itself, they can see that something is being worked on. As a result, this transparency and traceability that can be created in OpenCLM clearly offers added value to your company and can also be increased. So that's Anna Wagner. Thank you very much for that. Very interesting insights, and great that we could follow along using this practical example. Of course, we have to remember, if there weren't ever any changes, the digital thread would be very easy to achieve. But obviously, realistically, these sorts of changes are an everyday occurrence. So how can we make changes across system and domain boundaries traceable? Senior Product Manager Mirko Theiss is here to explain. He's also responsible for the integration solution OpenPDM and also the PROSTEP product platform. I'm looking forward to hearing what he has to say.
Thank you very much, Ms. Bauer. I would also like to welcome you to the PROSTEP Insight Days this year. As Anna and Rainer have just shown you, with our product OpenCLM, we can effectively link the data of digital thread with each other. That means generate traceability, also an impact analysis, the changes that have to be carried out in the domains. And now I would like to talk about how my authors, my planners, can be informed about having to carry out these changes. In the impact analysis, we have already seen that changes are carried out or have to be carried out for requirements management. That means we have new requirements for the Mars rover which have to be implemented. Sensors have to be updated. Also, the software of the respective sensors have to be updated. That means the application lifestyle management comes into play. And last but not least, our chassis has to be improved. That means the mechanical design has to be improved as well. And we have to inform our planners that they have a task that has to be carried out in order to improve our Mars rover. And the question is, of course, how can these planners be informed about the fact that they have to change something and improve something? They're working in their domains, in their applications, which they can carry out their tasks, ideally. And that's where engineering change management comes into place. That means we generate engineering change in the respective authoring systems, inform our planners what has to be changed, what data they have to change things, why they have to change these things, and of course, who is meant to change it. And if we look at the example of our Mars rover once again, then we have seen in OpenCLM we can carry out an impact analysis. That means change has been identified in OpenCLM. We also know in which domain this change has to be carried out in. That is the requirements management, application lifecycle management, and mechanical design. That means the data which are managed in the product data management. The question is, how can we do this? And you're already aware of this. OpenPDM comes into play. That means we have to take data and copy it into another system, synchronize it. The simulation, which we've determined in the impact analysis in OpenCLM, and has to be made available to the planners in their respective applications in a transparent manner. So we have a change we've determined in OpenCLM. We've got sub-changes, each in requirements management and an application lifecycle management or mechatronic design. And what the result looks like, we're going to look at the result now first, before I show you in detail how such an integration can be carried out with OpenPDM, and we're going to look at a video. We can see here the software Jira. At this point it's cloud software. That means we also have cloud software connected. We've got our Mars rover, and within this Mars rover an engineering change has been triggered with OpenPDM. That means the planner can inform himself what requirements are now new. He can define the requirements specifically, and that way he can define for his colleague how the planning should be changed. We have respective similar sessions in the other applications, SoftBeamer and the MC and PLM experts. Also, we've got a change here which is triggered by OpenPDM. And if we look at this change in detail, then just in the same way, we're going to see that there is information which describes how the sensor software is to be changed. and what has to be carried out. That means the planner at this point does not have to leave the application. All the information for this change can be found in CodeBeamer, his software. And last but not least, of course, the typical mechanical design at this point managed by Windchill. That means all the mechanical design is saved in Windchill. And there's a change here. If we open this change, we've got the respective description, but we also have information what product it belongs to, the Mars rover, and also that our chassis, the bogie, is to be changed. That means the planner can determine the information he needs and can see instantly, okay, the chassis has to be stabilized, it means it has to be changed. Our example here is a small example of our Mars rover, how data can be synchronized between different applications with OpenPDM, and you know that we've been doing this for more than 20 years with OpenPDM, and I think, Ms. Bauer, at this point we could have a customer comment on this.
That, Mr. Theiss, is a very, very good idea. We thought we'd take the customer and printing press manufacturer Koenig & Bauer, and they gave us a video which shows very clearly how KBA integrated its PLM and EAP landscape together with PROSTEP, and it also looks a little bit at what the aim is, so let's play it.
My name is Christian Petrovic. I work for Koenig & Bauer and I'm responsible for technical applications. The technical applications include the entire CAD world, management of CAD data in PLM systems, and also additional documents which are used in our processes. Koenig & Bauer is a very traditional company within printing technology. We print everything that does not reject ink. We have a broad spectrum of substrates that we print on, and as a print machine maker, we have an international set of clients. A main focus of the corporate strategy is digitalization. Digitalization, on the one hand, we mean digital products being put on the market on top of the purely engineering products, but also that our processes are digitalized, and through digitalization we can increase efficiency in our processes. With respect to our corporate strategy in digitalization, an important project which we've been working on recently is introduction of S/4HANA as a centralized ERP system in the company. The objective is unified and standardized projects which are continuous throughout the company. A further aspect is that, of course, our engineering projects have to be established in such a way that in downstream processes they're well integrated, and for this purposes we have our product data management system, our PDM system, with OpenPDM, with the downstream systems. It's well connected. That means master data management systems and ERP systems, sub-SVD, sub-S/4HANA. And the result of this integration is that we have a change management process which is pan processes and throughout the company, and at every point in the company it shows the user what the current status of development is and the current release status of machine components from which our machines are then built up with. A further aspect is that the information that we have with our machine data is available in a consistent manner, not just in our systems, but also in the processes which are supported by these systems. That's the current status of our work within digitalization, internal processes. What do we plan for the future? Two essential topics are, on the one hand, we want a real 3D master in our CAD modules. 3D master means that we're in engineering at the moment. A lot of things are still based on drawing. We want to get away from the drawing. We want all management or production relevant information for downstream processes available in the 3D models. That means that we have continuous processes all the way into production. That is one aspect that we're going to be dealing with in the near future. A further aspect is digital product twin, so that we're able to take the specific product machine and present it as digital mock-up and be able to work on that further. Greetings to PROSTEP Insight Days from Koenig & Bauer in Würzburg.
Thank you, all the best from us as well. It was a great video. What's important to emphasize here is that it's PROSTEP's software OpenPDM which forms the basis of this integration solution. Perhaps it's now a good time to look at how it's set up and or what its strengths are, and to do so, over to Mr. Theiss again.
Thank you very much. Based on our Mars rover, we have now seen how such an integration can be carried out. and how the results can be synchronized between systems. Our customer, KBA, also mentioned that, how KBA did that between Teams Tester and SAP as an example. Now the question is, how do you build such an integrated system? And for that, I'm going to put on my hat as an administrator. Normally, you don't really see anything of OpenPDM because the data are synchronized in the background so that they're available at the right place at the right time all the time. But in order to demonstrate a bit of OpenPDM, we're going to act as if we were administrators, and we'll have a look at how this can be developed. And we're going to start with the requirements. What requirements do I have when I have a digital thread I want to set up? And the general requirement is, of course, that all required information has to be available at the right time at the right place. That means in the different domains. I always have a source system where the data are generated. I have a target system where these data are processed and used in order to generate new data. The whole thing is triggered. That means I have a trigger for the synchronization. Somebody, for instance, releases this change to the steering committee or something similar to make it clear that these changes, these tasks can be carried out and the data can be synchronized. And last but not least, of course, it's relevant what information. There, the source system is the main aspect. I need all the relevant information, all relevant objects to be exported from the source systems. Then generally in heterogeneous system, I have various systems. That means I have to map between different data formats. That has to be done in a homogeneous fashion too. And last but not least, these map data have to be imported to the target system. And that is typically done with an indication platform, OpenPDM, our integration platform. And this process, which I've just hinted at, has to be orchestrated, it has to be carried out, and then the data have to be synchronized when the right time has come. The right time in OpenPDM is always when a trigger is actuated. That means you define at what time data are synchronized between systems. These can be manual triggers. Your staff could trigger an action in their normal everyday work. Then OpenPDM starts working in the background, but these could also be processes or time-based triggers, or we'd recognize that suddenly a target is in a particular directory. Then it's important, and we've seen that in the previous slide, we always have source and target systems. So we're living in a heterogeneous world. We have various systems. We need connectivity to these respective systems, the authoring systems. And for this, OpenPDM provides a plurality of out-of-the-box connectors. Of course, not only for the connectors or for the systems that we have in our demo example today, but also for a whole lot of other systems, other providers. We have a very broad connector base. I've already addressed this. We're talking of different systems, different data patterns. That means we need a mapping service which can frictionlessly map data from the source to the target and provide the data in such a way that we can import them without any loss. And last but not least, let's not kid ourselves. Systems might not be available, things might fail, mistakes happen. That means we need effective monitoring functionalities so that failed processes and the system failure can be started again, and ideally, of course, it should be done starting from the integration platform itself. That means the monitoring component is essential for such an integration platform. And last but not least, you already know this, you're not only starting with digitalization now, you have services internally yourselves which you want to use in such an integration. And OpenPDM is so flexible that for services already present, you don't have to reinvent the wheel for OpenPDM. We integrate them in the processes and then the whole thing works and data can be exchanged between your systems. I've already started by saying that we have processes, we have workflows. That means we have a defined path when at what time data are synchronized. In our case, the trigger is the release through the steering committee. Through our impact analysis, we have to export data And then we have three systems in which we can import the whole thing. And how all that is modeled, how such processes are modeled, is what we're going to look at in the next film. What you can see here is the low-code modeling functionality of OpenPDM. Our workflows can be based on Camunda. Here we've got a low-code modeling, and at the beginning of a project we're going to provide a workflow template. That means all the basic functions, like for instance exception handling and reporting, are already present in this report. So inlines are present as well for the source system, so all actions that can be carried out with the source system for mapping, and last but not least also for the target system. How can this workflow be modeled now? If that happens graphically, that means such a task can be drawn into my interface. It would make sense for me to name it right away so that it describes its function and link it to OpenPDM itself. That means at this point I'm linking it with an OpenPDM connector. I want to export data from one system. That means I'm using all the functions of the connector. Select export and at this point say please export. That means I've now defined what this is to do. The question is, how are the data processed? That means this task, this export process, has to be told what source data it is to use in order to carry out the export. That means I'd state a variable, and in this variable it will find all the information, the source ID for instance, of the export information. Now the question is, where does this source ID come from? Let's have a look at the beginning of the process. The trigger hands over this source ID, which is a variable which is handed on in the process and can be used and processed. Once OpenPDM connector has done its job, that means exported the data, then the data has to be passed on another variable because we have further steps, and here I'll just define a variable name. That's how easy it can be in a low-code interface to communicate with OpenPDM. All my processes can be orchestrated. I want to demonstrate the further steps very briefly, but we'll just act as if we were working really quickly, and we'll wind forwards a little bit. You can see the mapping step is linked just the same with OpenPDM, and the respective variables are defined, and the import step into the target system is modeled in the same way. That means a consistent flow, the workflow can be reflected, and the whole thing has been modeled in OpenPDM. After we've modeled it, of course, it's important to deploy the whole thing. That means on the process server from OpenPDM, the service can be made available, and of course I can do that in my development environment right away. And the template OpenPDM can be made available, what can be expanded as necessary when the respective triggers are activated. So if this process is run across our workflows which we defined beforehand, then we've carried out what we want to do. That is, set up integration. The source and the trigger OpenCLM, we've got the process which we've orchestrated, and we use three OpenPDM connectors, Jira, Codebeamer, and Windchill connector, so that the respective sub-changes in the systems can be set up. We've just seen the result, but of course we want to have a look and see what the administrative interface of OpenPDM looks like, and what does it look like when such a process which we've just modeled is initiated. Now we're going to log into the administrative interface. We can see a process is still running actually. Integration to Windchill is now completed, and we can look at the details. I can look at the process instance, and graphically I can see precisely the process I was just modeling. Everything is green, everything is done successfully. I can identify how long the individual steps have taken, and for all three systems you can see the processes have been carried out, data has been synchronized, and we've just seen the result. Now, not everything works all the time, as I pointed out. Mistakes do happen. I've just given you an example. That means if an error occurs when a service is requested, it's illustrated in red, and you can go to error reporting right away and find out why the process failed and start it over again. At this point, we have now synchronized the data. That means before, Anna and Rainer showed you how the data are linked, how the data in the different domains are linked. And now with OpenPDM, we have the option to synchronize data in between the systems for the planners so that the data are available in the authoring systems. So that finally, the users don't have to switch their authoring systems, but all the data are at the right place at the right time. And Anna, I can tell you, while I was modeling and presenting OpenPDM, our planners have been working diligently, and it would be quite interesting to see in the digital thread. Can you show when they're finished in OpenCLM?
Of course I can, Mirko, thank you. Jumping to OpenCLM now, we can see what changes have occurred. We click directly on the overview of our solution development for the tilt sensor. And we can see these little chips and cards are now blue and green and not pink like they were before. This means that the internal release workflow of OpenCLM has been completed. This release workflow ideally changes to the published status, which means it was successful. We have release 2 here, which was generated in CodeBeamer, and this release has been published in OpenCLM and cannot be changed as a result. So this application case of this change process has now gone a full circle. And I think we will now show you a video from one of our customers. Yes, just checking with our customers, that is correct. And one of them is the SO system, which works very closely with PROSTEP on integration solutions. And we thought we would prepare a video for you to show the advantages this has for SO and PROSTEP, but also for SO systems customers.
My name is Arko Sucic, and I work for Dassault Systems in Central Europe in Industry Consulting. Dassault Systems is the second biggest company in application software after SAP. We're market leader in CAD systems, PLM, but also innovation of complex products and technical systems. As Dassault Systems, we try to get product, life and nature together. We try to do that with digital or virtual twins. These virtual twins are to serve to help companies in digitalization because we try to take complex systems, complex appliances, to describe them in such a way so that throughout all cycles in a life cycle they can be accompanied and supported. Digital twins are not to be seen in isolation. They have to be integrated in our customers' IT systems. That is why the question of good integration is decisive for the success of use of digital twins. Dassault Systems is trying to work together with ecosystems to address these questions and provide solutions on-premise and also on the cloud. PROSTEP is part of Dassault Systems' ecosystem. For us, it is very important to have a good partnership with PROSTEP because in integration we have mastered several successful projects already, but we still want to go a step further. We don't only want to carry out integration together, but also cooperate even more closely in consulting because we support our customers from the first idea to implementation of the software so that we can reach success more efficiently. I wish you successful PROSTEP Insight Days. Best wishes to Darmstadt.
Short and sweet, thank you very much for that. We've heard quite a lot of information, so we'll sum that up for you in just a moment. Just one reminder from me first. We'll have a Q&A session after the next presentation. So if you have any burning questions, now is the time to write them in the comment box here at the bottom of your page so that we can put them to the speaker for you during the Q&A. To sum up what we've already heard today, I'll hand back over to Mr. Theiss.
Thank you very much. I will gladly summarize everything we've seen so far and how our digital thread has been reflected so far. At the beginning, we saw how with OpenCLM you can achieve linking of various different planning domains. In our case, the example of requirements management, application management, and product data management, or mechanical design. After that, with OpenPDM, we have seen that the data can not only be linked between these systems, but the planners can also be given the data directly in their authoring systems so they don't have to switch their applications. That means that data can be synchronized between systems with OpenPDM. That means copied. And Anna has already shown us this. The whole thing has been carried out in requirements management and application lifecycle management. What remains open is mechanical design. Why is that still open? Mechanical design is carried out between suppliers in our case. That means the data have to be transferred to our suppliers from our own system. They have to be informed that they have to do something, and that will be the subject of our session this afternoon. That means if you want to see how the digital thread continues and data can also be made available outside of our small data demo company, welcome to our afternoon session where OpenX is going to be presented. At this point, we have achieved our first steps, and supplier integration will be this afternoon, and we're looking forward to hear your questions.
Exactly. Thank you very much. Some of you have already submitted your questions. You can continue to do so throughout, so please do so. I'll be showing them all in real time on my tablet. So I'll read out what we've already received, and we look forward to our experts' answers. The first question is, can OpenPDM only synchronize metadata and structural information or documents as well?
I think I can answer that right away.
Please do.
The good news is, yes, of course, we can also synchronize documents. Today, in this demo, for simplicity's reason, we synchronized metadata. We did not demonstrate that we could also synchronize documents, but of course we can also synchronize documents in our day-to-day business like Word, JT, PDF, but also CAD data is very important to be synchronized between planning domains, and OpenPDM can also do that, and our customers do that in a day-to-day business.
So that's a yes, thank you for that. Next question. Is the OpenPDM integration platform only available on premises, or can I also get software as a service from PROSTEP? I think you'll be answering that as well.
Yes, I will try and answer that as well. Today, I would say 99% of our customers and our projects are on-premise, but we have already seen this. Jira ran on the cloud. We're on the way towards offering software as a service. This afternoon in the roadmap, I'll show you a few starting points, how we want to make software available as a service, and for the future. The clear objective is that the entire OpenPDM's platform is to be made available as software as a service. That means PROSTEP is working on this, and you can use it on our platform.
Thanks for that. I have another question, and I think you might be answering it as well, but let's see, maybe I'm wrong. What do standards like STEP and SysML mean for the solution you've presented?
I'll just pass that one on, I think. I could answer, but my colleague should have a go as well. Well, it's clear. As we cover the entire product development process with OpenPDM, SysLM plays a role in the whole central engineering, and SysLM import is also a basis for OpenCLM integrated, so that with SysLM import we have a basic framework, and that is then a basis for linking.
Thanks for that. Another question just popped up. Can you connect systems to OpenPDM to which PROSTEP doesn't offer any connectors?
Again, the answer is yes, you can. All systems that have any kind of interface can be connected with our connector template to OpenPDM. Our standard connectors are also based on this connector template, and that way you have the advantage that we or you yourself can implement precisely the use cases. All you have to do is read, and any system can be connected to OpenPDM if you have an interface.
So I'm almost qualified. I can read. We've had many good questions there. Thank you to our experts today, and thanks to you as well for getting involved. I can tell you that we'll continue at 12:30. We've just looked at how the digital thread can be established in businesses. Now we want to look at the digital thread in the supply chain. I look forward to seeing you again at 12:30. Enjoy your break.